Greeting. Peace be with you. In this video, I am going to show how to capture picture with ESP32-CAM microcontroller board, save and display the captured picture to Android mobile phone with the help of DumbDisplay. As well, live streaming of pictures captured by ESP32-CAM board is also an aim of this experiment. Arduino IDE will be used for development of the program. Most of the details of programming the ESP32-CAM board are borrowed from the GitHub project ESP32-CAM Development Board Demo. The ESP32-CAM board used is an AI Thinker ESP32-CAM board, with an OV2640 camera attached. ESP32-CAM-MB USB Programmer board is used as an easy way to upload sketch via USB cable. To aid saving and displaying captured pictures to Android mobile phone, DumbDisplay is used, and ESP32-CAM board's internal Bluetooth is used as connection mechanism. Basically, other than USB connection, there is no other wiring at all. So, let's start reviewing the sketch. Lines 1 and 2 include the core library's header files. Line 6 defines the macro Bluetooth. If you want to use Wi-Fi instead, comment out the line. If the macro Bluetooth is defined, lines 10 and 11 declare the DumbDisplay object using Bluetooth as connection mechanism. Notice that the name ESP32-CAM is set as the name of the Bluetooth device. If the macro Bluetooth is not defined, lines 15 to 18 declare the DumbDisplay object using Wi-Fi. Note that as Wi-Fi if used, you will also need to appropriately set the constants SSID and password with the SSID and password of your Wi-Fi router. Lines 25 to 27 declare some constants. The constants image layer width and image layer height define the dimension of the area where to display the captured image. The constant image name is the file name used when saving the captured image. Note that the same image name is used for all image capture, hence, only the last saved image will appear in your phone. Lines 30 to 34 declare 4 variables to host 4 DD layers. 3 LCD layers acting as buttons. They are flash layer, to switch between on and off of the flash when capture image. Resolution layer, to switch the resolution of the captured image. And capture mode layer, to switch between capture a single still image or continuously capture and stream images. The variable image layer holds a graphical layer acting as display to show the captured image. Lines 36 to 44 declare the routine create and setup button, which is used to create and set up a LCD layer that simulates a button. Lines 46 to 53 declare the routine create and set up image layer, which is, obviously, used to create and set up the graphical layer, on which captured image is shown. Lines 56 and 57 declare the headers of 2 routines. The routine initialize camera is used to initialize the camera attached to the ESP32-CAM board. The routine capture and save image is used to capture an image and save it via DumbDisplay. Both routines will be declared later in the sketch. In the setup block, line 61 to 63 create and set up the 3 button layers mentioned previously. Line 65 creates and sets up the image layer. Lines 67 to 70 instruct to pin the different layers in the desired way. As the last statement of the setup block, line 72 draws the DumbDisplay logo image on the image layer. Note that the logo image file comes with DumbDisplay app. Line 76 declare the variable camera ready, that tells if the camera is ready for capturing image. Line 77 declare the variable flash on, that tells if flash is on when capturing image. Note that the variable uses DD value record, that aids keeping track of the varying of the variable value. Line 78 declare the variable image size, that tells the resolution of the captured image. 1 for 640 by 480, 2 for 800 by 600, 3 for 1024 by 768, and 4 for 1280 by 720. Line 79 declare the variable streaming that tells if it for streaming images, or just for capturing still image. Line 83 to 89, based on the value of the variable flash on, print out different labels to the flash layer. Note that because of the way how the DD value record works, the labels will only be printed once when the value of the variable is changed. Line 91 to 97, based on the variable streaming, print out different labels to the capture mode layer. Line 99 checks to see if the value of the variable frame size changed. If the variable changed, lines 101 to 121 set the local variable image size to the corresponding image resolution, as well as print the corresponding label to the resolution layer. Line 122 to 128 initialize the attached camera to use the value stored in the local variable frame size as resolution for capturing images. Line 131 to 133 test if there is a layer feedback from the flash layer, that is, the flash layer is clicked. In such a case, the value of the variable flash on is toggled. Line 135 to 141 test if there is a layer feedback from the resolution layer. If so, the image size variable is incremented. Line 143 to 145 test if there is a layer feedback from the capture mode layer. If so, the variable streaming is toggled. Line 147 sets the local variable capture that tells if there is a layer feedback from the image layer. That is, the local variable capture will assume the value true if the image layer is clicked. Line 148 checks if the capture is true or if it is streaming when camera is ready. If camera is ready, as checked by line 149. Line 150 calls the routine capture and save image. Note that the first parameter of the routine is use flash, and the second parameter is cache only. If capturing of image is successful, line 152 and 153 unload the image cache to the image layer, and clear the image layer as well. Line 155 draws the captured image to the image layer. Note that if the image is not cached, it will be loaded and cached. In case the capture is not successful, line 157 writes the appropriate error message as comment to the DumbDisplay app. In case the camera is not ready, line 160 writes out the fact as comment. Line 160 to 159 declare a bunch of values for setting up the ESP32-CAM board. As a matter of fact, this portion of the sketch is borrowed from resources that can be found in the Internet. Line 199 to 216 declare the routine camera image settings. Again, this portion of code is borrowed. Line 220 until 282. Again, those many lines of code are borrowed. Line 285 starts declaring the routine capture and save image. The first parameter, use flash, tells whether the bright LED next to the camera should be used as a flash during image capturing. The second parameter, cache only, tells whether the captured image should only be cached, or should actually be saved to your phone's storage. In the routine, lines 286 to 288 instructs the ESP32-CAM board to capture image. If use flash, turn on of the bright LED during image capture. Line 289 to 292 check the result of the capture. If null is returned, that is failed, return failed. In case cache only, line 295 caches the captured image to the image layer. Otherwise, lines 297 to 299 save the captured image to your phone's internal storage. Line 302 releases the memory used for capturing image. That is it. Let's try it out. Assuming that your Arduino IDE already installed with ESP32 support. Make sure that the board AI Thinker ESP32-CAM is selected, and the correct port is selected. To upload the sketch, you will first need to restart the ESP32-CAM board, with the I/O0 button of the programmer board depressed. To restart the ESP32-CAM board, you can either press the reset button on the ESP32-CAM board, or unplug and then re-plug the USB cable. After uploading the sketch, restart the ESP32-CAM to kickstart the sketch running. On the DumbDisplay app side, you will need to grant to DumbDisplay app permission to write to your phone's internal storage, as shown.